So here's an example from the textbook from section 9.3. We have a sample of non-English majors, and we're using them for two different experiments. Go ahead and pause the video, write this down if you need to. I forget what number, I took it from the textbook. Pause the video. Once you're ready, turn it back on. So each of these students, we gave them a book to read, and then we gave them a test. And we then at another point in time, it gave them a DVD of a different book and had them watch the movie instead and then take a test. And we wanted to see, we want to conclude whether or not the book scores are higher than the DVD scores. So these samples are dependent because the same student took both tests. We have to assume or be told, and it was in the exercises, that the sample size is either large enough, over 30, which it's not, or that the population is normally distributed. And so we'll assume that that's the case here in this example. We want to know then whether or not overall we can say that the book scores are higher than the DVD scores. When we set up our null hypothesis, okay, if we think about our book scores as being our first population, the students there, and the DVD people being our second population, okay, we want to test to see whether the difference of those two means is 0. Or whether or not if the book scores are higher, that means if I subtract those two means, I'm going to get a positive number. So what we're looking at here is a right-tailed test. Okay, and we're going to need to figure out what that test statistic is along the way. We know that our degrees of freedom are 1 less than the sample size. And if we count across, we have 1, 2, 3, 4, 5, 6, 7 pairs of data. So degrees of freedom would be 6 here. If we check for degrees of freedom, 6, we check for an alpha equals 0.05, and we have a right-tailed test, which is one tail. That tells us this t-score here for our rejection region is 1.943. So now that we have that set up, now we have to come up with all of our other data. I'm going to find that page here. We need to find the difference between our two x's. We need to find the mean of those d's. We need to find the standard deviation of the d's, and then our s sub d bar. Then from there, we'll use that to find our t-score and say, are we in the rejection region or are we not? Okay. I used Excel to write those things down. And that's kind of in the way. And so Excel is going to be very helpful to me. I'm going to need to not use my finger on this. If we want to compute these, we're going to need to find an x minus x1 minus x2. We're going to need to find all of those guys there. I don't like that I have to do this every time. And we're going to have to square them to find the standard deviation. Okay. I do not mind at all if you use Excel to help you on these problems. We also know that n is equal to 7. I'm going to take a picture of this so I can draw on it in my slide. I don't know what that big line is there. So my x1 values were here. Okay, these are my x2 values. If I take x1 minus x2, 90 minus 85, 80 minus 72, on down the line, okay, that gives me my d's. If I want to find the mean of the d's, I'm going to have to add those up. Okay, notice I have a sum column, or a sum row down at the bottom. Okay, for the standard deviation, I'm going to need those differences, I'm going to need them squared. So if I want to find d bar, if we look over here on the right, I'm going to add up the d's and divide by n. So the sum of the d column is 47. We had 7 pairs of numbers. Since these are whole number values, we're going to round to 1 decimal place farther, which means to the nearest tenth, and we'll call that 6.7. If I want the standard deviation of that set of pairs, okay, it says we need n, which is 7, times the sum of the d squares. Okay, d squared was that far right column. That adds up to be 555. So I kind of left myself enough room. We're going to subtract the d column, the sum of the d's, that thing, squared. So minus 47 squared. On the bottom we have n and n minus 1. N was 7, 1 less than that is 6. I think I wrote down details here for those of you who put middle pieces in. Again, our calculator, if we're careful enough about asking it these questions, we can type this in all in one piece. Okay, but most of us don't know exactly and we aren't comfortable with getting that all typed in all at once, so we plug in these middle steps. Okay, I didn't write down what that was underneath the radical, but once we take the square root, we get 6.3. So again, this is our S sub D. What happened there? Okay. When we're doing our hypothesis test, then, okay, I'm going to make you dizzy. I'm going to go to the right one more time. Okay, we need to figure this value here. And that's what we're checking and testing to see whether or not it falls in our rejection region. Okay, so for that t-score, we're going to take d bar. In our hypothesis, our null hypothesis, we had a 0 there in our null. On the bottom, we have our standard deviation that we found was 6.3 over the square root of the sample size, which is 7. You type these things in. Again, pause the computer along the way if you want time to make sure that you can type these in and get these numbers out. Watching me do math is not the same thing as you doing it on your own. So make sure you're pausing the video, type it in, make sure you get 2.814 out of that. When we look at 2.814, compare it to our cutoff of our critical or of our rejection region there, 2.84 is to the right of 1.943. So that means we are going to reject the null hypothesis. Okay, when we reject the null hypothesis, we have to explain what that means. We're going to say there is sufficient evidence to support the claim that the book scores are higher than the movie scores. I did notice that these are some pretty amazing scores. No one scored less than a C on either test there, so they had a good group of students that they used to do this experiment with. This is the only example that I have set up from this section. If you need to watch it over and over again, please do. Your author puts some in the text, and they are explained very well. It's a lengthy process. Again, Excel is a good place to go, so you're not adding up all of these things by hand. That can cause human error. But please contact me if you're not sure what to do on a problem with the dependent samples here.